Hi everyone. Today we're going to look at a PLC programming example of a pick and place robot. And what you'll see is up on my screen here, we're going to use the 5 steps to PLC program development. And the first one is defining the task. What do you really want to do? So on my screen here you'll see I have a conveyor with a robot, and we have incoming items coming down the conveyor, which will start. We have a photoelectric that will actually sense the object presence. Then we'll have a robot arm come down in the Z-axis. It will pick up the item. It will then come up, and then it will go forward in the X-axis, then go down in the Z-axis again, and then set it down on the exit conveyor, which also has a sensor detecting when the product is there, and then it will go back up, and then the item will then go down the conveyor belt and then down the chute. On the actual unit we also have a control panel, and the control panel will have an emergency stop. We have a start, stop, and a reset button, and we have an auto and a jog. So when the jog is in, we want to be able to hit start and just cycle through the robot movements for us. We also have the reset. When you hit reset, it resets the sequence of operation back to the start. Also, if you hit and hold the sequence or the reset button, the counter will then go back to 0. Now the other issue is if anything happens on this conveyor belt and boxes move out of the way, etc., we want the item to stop, or the system to stop, and actually display on our display a corresponding code, which we'll put in negatives, that will actually show where the error resides. So in our 5 steps to programming, the first thing is defining the task. That's what we just did. The second thing we have to do is define the inputs and outputs of our system. So if we look back on Factory I/O, we'll look at the drivers, and in here what we have is our sensors. So we have our auto and manual, our e-stop, then we have our item at entry, exit, detect, and what we do is we marry that up to our coils that we use on our Modbus TCP communication back and forth. So don't worry about all that. What we'll do is just basically mimics the inputs and outputs of what we're looking at. So here's all my inputs and my input coils, and then I have my outputs. So I have my entry conveyor, exit conveyor, we have move X, Y, we have a grab, and then we have our lights, our start light, reset light, stop light, and then we have a counter, and that counter value is our holding register 0. So that's where those are coming from, and that corresponds again to our conveyor belt system in our pick and place. So after we've defined the inputs and outputs, then we have to define the logic or sequence of operations that we want to happen. This is the most important stage when developing PLC programming. And up here on my screen, what you'll notice is that we actually have a table laid out with the sequence of operation. Here's all of my inputs as well as a couple of outputs that I've indicated, and all of these links can be found in a guide that we had that you'll find on our website. So we have all these sequence inputs, and then we have our outputs that we want to have happen. So our step 1, if we have all these conditions true, then what we do is output sequence output number 1. Then it goes and looks for sequence number 2. When that happens, then we do 2. So we go down the logical sequence till we get to the end. Then we come back up and look at the beginning again. So basically we're just writing out a flow chart as exactly what we want to happen within that PLC. So once we have that, we define the logic and we know exactly what we want, then what we do is we develop the program. So it's the second last step. This is step number 4, is develop the program. So now what we do is we take our logical sequence and we then look at controlling this. So basically we have a start bit that we've did in our sequence. So there's my start conditions. that happen. Then what we do is we set up our input channel, and we set up our output channel, which is further on down here. And then in the middle here, what we do is we use our sequence logic, and what we're doing is looking for the input channel conditions and setting the output channel conditions. And then our logical resets, and then our output channels that we have there, and then we have our start-stop light controls that we use. And then what we have is our reset control. So if we hold it for more than 3 seconds, then we zero that counter. And then finally we have our counter. And once we have our item at the exit, we increment our counter. When any of the display items happen, or the error messages, then it corresponds to our output status and what's happening within that controller. And how we do that is we look at our sequence and our input conditions, and if our input conditions are not the same as our output and it's waited more than 10 seconds, then what happens is it actually will move the counter into a holding register or another register, and then it will do some math to figure out what bit is actually not on. Then we look for that bit that's still on, and then we give it a number. Once that we have that number, we multiply by -1 to give us a -1 indication of our display. When that happens, then we'll actually see that on our display exactly where that negative number is. And then what we do is reset the timer. When the timer's done, we move that value back in again so that we know our exact count. So at the very top of the page, what we'll do is, because we're using factory I/O and simulating this pick-and-place robot, first of all, we set all of our inputs and outputs. Now our inputs are the coils from our factory I/O, and they're going to an actual input that we specify. So there's my item at entry, exit, moving, X moving, Z, item detected, start, etc. And then we have our factory I/O outputs. So our output area here would actually maps into our BRX controller. And all of the Modbus addressing in the BRX controller actually go as a separate identity altogether. So we have Modbus holding registers for like the counter. Then we have the Modbus inputs, Modbus outputs areas. So there's all of those, and then we're back to our start. So we develop our program based on our sequence of operation. And then the fifth step is the actual testing of the logic in the program. So if we look at our PLC here, we'll just flip this over into manual mode, and when we do, we hit the start, and what we should actually see is just the arm moving. So there's my arm. Oh, moving that way, then we move it down, back up again, then back over, and we're back to the original. So we can see that we can move that arm, and we'll just move over here. See if we see a little better. We can do that again. So down, back up, over, down, back up, over. Okay. So now what we'll do is hit reset, and we'll go into auto mode, and then what we'll do is we'll start the process. So we can see that actually moving over and setting it down, just as our sequence of operation has suggested. So here's all of our steps here as we go through them, and you can see that my BRX controller and my outputs conditions are being set every time that we are changing those outputs. We can also go back to our PLC, and we can actually then see the I/O inputs channels changing and our reference values changing. So this is how we actually are going to test out that PLC altogether. We can look through Factory I/O at different angles of the exact operation of the controller. There's our angle. Look at more like this. We can look at the exit. Back to start again. If we don't like the angle, we can actually zoom in, zoom out. We can actually go around and view exactly what's happening at each spot. We could also do a first person and actually monitor and watch as an item gets through the whole system. So there's it being picked up. And to the exit again. So we can also do things like move boxes around. You can see I can move the little box here or there. Made that a little crooked. Oh, see it didn't pick it up now. So what we can do is we'll look at what happened and look at our control. And right here is that represents the 0. And the 0 actually means that we have trouble with our incoming conveyor, which is exactly what happened. Let's just stop that. And what we'll do is just get rid of that box. Okay. And we'll just reset. And we'll start up again. There we go. So test your program as much as you can in order to get all the bugs worked out so that you don't have to be called back onto the site. All right. Now, all the links and documentation can be found at our website at accautomation.ca. And if you like this video and like to see more, there are 3 ways in which you can help us out. You can give us a thumbs up so other people can find this information just as you have. You can subscribe to our YouTube channel at the end of the video. You can also go to accautomation.ca and subscribe to our website. When you do, notification will be given to you every time we publish new content to the site. You'll also get 2 free ebooks on numbering systems and robust data logging. And the third thing to do to help us out is to tell a friend or colleague about the site. Alright, that's it for now. Thanks for watching.